All right, so you sent over a ton of articles on the 2024 Nobel Prize in Chemistry. And one thing's for sure, proteins are having a moment.
More than a moment, really. This prize is a seismic shift in how we view, and honestly, how we can now work with the fundamental building blocks of, well, everything.
Okay, now you've got me hooked. But let's unpack this a bit. 3 scientists, 2 research areas. It's a lot, right?
Yeah.
How does it all connect?
Right, so you've got David Baker, who snagged the prize for computational protein design, and then Demis Hassabis and John Jumper, recognized for predicting protein structures. Picture this way. Baker's like an architect, yeah. But instead of buildings and blueprints, he's using lines of code to create brand new proteins with specific functions.
So not just tweaking what's already out there, he's designing them from scratch. That's mind-blowing. I mean, what can you even create at that level?
We're talking about proteins as tiny machines, doing things never seen in nature. Baker really blew the doors open back in 2003 when he created Top 7, a protein that never existed before. Total game changer, right? It proved we weren't limited to just tinkering with what nature already gave us.
Okay, huge implications there. But where do Hassabis and Jumper fit into this? If Baker's designing these proteins, what are they predicting exactly?
They cracked the code on predicting how a protein will fold, its 3D structure, just from its amino acid sequence.
Right.
Like, imagine figuring out the exact shape of a 1,000-link chain, just knowing the order of the links.
Sounds impossible. How'd they even begin to solve that?
AlphaFold. Their baby, an AI program that uses deep learning to predict those structures, and it's crazy accurate. It was revolutionary. Suddenly, scientists had this tool, could explore the protein world in a way they could have only dreamed of before.
So we've got 1 scientist making new proteins and 2 more figuring out how to map them just from a sequence. It sounds like the Nobel Committee is saying these 2 achievements are 2 sides of the same coin, right?
Exactly. Can't have one without the other if you really want to grasp and, more importantly, harness the power of proteins. Designing them is incredible, but useless if you don't know how they'll act in the real world. That's where predicting their structure becomes so crucial.
So this Nobel Prize is about more than just these 3 brilliant minds. It's about recognizing a fundamental shift in how we approach biology and medicine.
Absolutely. This isn't just science anymore. This is where science fiction starts to become reality.
Okay, so now my brain's buzzing with possibilities. We're talking about building proteins from scratch, understanding their blueprints. This has got to be the key to unlocking solutions for some of the biggest problems we face, right?
No doubt. The potential here is massive. Think about personalized medicine. We could be designing drugs that target specific proteins involved in a disease, but, and this is key, tailored to your unique genetic makeup.
So no more one-size-fits-all treatments. Everyone gets a solution designed just for them. That's incredible.
Exactly. Fewer side effects, better outcomes. It would transform healthcare as we know it. And speaking of transformations, think about vaccines. Remember the scramble to develop the COVID-19 vaccine?
How could we forget?
Well, imagine if we could use computational protein design to create vaccines for new viruses way faster before they even have a chance to become a global threat.
A rapid response system for pandemics. That'd be revolutionary. But this feels bigger than just healthcare. What about other things like, say, pollution? Can this technology help there?
You're right. The applications go way beyond medicine. Picture this. Enzymes engineered to break down plastic waste or neutralize toxic chemicals. We're even talking about building new materials, things that are lighter, stronger, and way more sustainable, all using proteins as the building blocks.
It's kind of mind-blowing, right? This tiny protein molecule might just hold the key to a whole new era.
It really is.
Yeah.
And what's so cool about all this is how this story shows just how powerful collaboration can be. You've got computer science, biology, chemistry, even a chess whiz in Demis Hassabis. It's like a reminder that the biggest breakthroughs often happen at the intersections when different fields collide.
Like they each had a piece of the puzzle, but together, boom, they could see the full picture, a solution that had been hidden in plain sight. Makes you wonder what other impossible problems are out there just waiting for the right people to connect and crack the code.
Absolutely. But as huge as the possibilities are with this whole protein design thing, we got to remember, it's still early days. Lots of challenges ahead, for sure.
Right, of course. So what are some of those hurdles? What are researchers grappling with as they dive deeper into this new world of protein science?
Well, one of the big ones is figuring out how proteins interact, not just with each other, but with their environment too. Like, we've gotten really good at predicting the structure of a single protein, but in reality, they rarely act alone, right? They're part of these crazy complex networks interacting with tons of other proteins and molecules.
So it's like we know the individual instruments in an orchestra, but figuring out how they all work together to make a symphony, that's the next level.
Exactly. We've got to move beyond studying proteins in isolation. We need new tools, new ways of looking at these intricate interactions. Understanding that language, the language of those interactions, that's going to be key if we want to design proteins that can actually function in the real world, in the messy, dynamic environment of a living cell.
It's like we've opened one door of discovery only to find another one, even more complex and exciting, waiting right behind it. Really puts into perspective how vast and intricate the world of science really is.
It really does. And honestly, it fills me with this sense of awe, of excitement for what the future holds.
Me too.
Yeah.
This deep dive has been a wild ride, that's for sure. It's definitely given me a whole new appreciation for the power of scientific curiosity, for the incredible potential that's out there waiting to be unlocked. And who knows, maybe one of our listeners will be the one to do it.
Yeah, wouldn't that be something?
It would. So to everyone listening, keep those questions coming, never stop exploring, and hey, maybe someday we'll be talking about your Nobel Prize winning discovery on a future episode of The Deep Dive.